Okay, in this video we'll take a look at scatter plots and a few variations on scatter plots. So in this one I have in my data one, that's the data set. X is going to be SAT score and Y is GPA. And I'm just going to put points. And there's just your basic default scatter plot. Now what I'm going to do is I'm going to add to both the Y and X axes something called a rug plot. And what it does is basically it's almost really kind of like a dot plot, except for it uses lines for each variable, and you can start to get some sense of how they are distributed separately. And so you can see along the line here that in the Y they're a little bit more dense in this area, and you can see not too, they're just kind of evenly spread out on the SATs. A lot of times what you'll see is it'll be light at the ends and then heavier as you get in the middle. A little bit here. That would indicate something like a bell shape if it were heavier in the middle and got lighter towards the two ends. Now I'm going to go to inside the AES, and I'm going to say that I want to have a separate color for each gender. And there we go here. And you can see that's reflected both in the rug plot and in the scatter plot itself. And I think I'm going to change the theme here. Let's go with Stephen Few's theme. Oh, let's go with the Wall Street Journal. Somehow I'm liking that right now, or for some reason. So we have that on here. And now what I'm going to do is I'm going to add a line to this, and to do that, I'm just adding another layer. It's stat underscore smooth, and then method equal LM for linear model. Okay, remember to put a plus sign there. And now we have actually two lines here, one for males and one for females. So you see the lines, and you can also see what 95% confidence bands around each line. You can see that looks like males have a little lower on both. A slight widening, but not much of one. Okay, you may, instead of a linear model, want to use a low S model, which is just sort of a moving average throughout the range here, and you can see that it's going to curve. And it does give you sometimes a sense of whether or not there's going to be a curvilinear relationship or a linear relationship. Kind of hard to tell what we have here. And now I'm going to go back to the linear model. I could do the same thing with the low S, but I'm going to say standard error equals false. So now I'm not going to have a confidence interval there. And I think I'm going to up the size to 2 just to make the line a little thicker. And we have that. Now I'm going to kind of grid this out a little bit. Let's say facet grid. And I'm going to do award by gender. Not that those make any sense at all in this particular case, why you would expect a different relationship of SAT and GPA for people who prefer different awards or different genders. Don't forget that plus sign right there, but it'll give you a sense of what can be done here. So now I have, for females who prefer different awards, Olympic, Nobel, and Nobel, it is Nobel, and Academy Awards for both males and females. You've got separate lines there. You can kind of compare intercepts and especially slopes of those to see if anything kind of sticks out to you. And let's say I didn't have a theme at all. And let's just see what the default would have looked like. And there you go. You can decide which of those you like. And then how about, I think one of them that I kind of like on these grid things is Stephen Fuse. You can get a look at what that is. And Tufty's similar, but he doesn't put the frames around it, and this is kind of just a matter of taste, I think. But I kind of, in this case, I don't usually like frame plots, but I kind of do. But here's what it looked like without them. And then adding back the confidence intervals, I can take this SE equal false out. And now we have the confidence intervals or confidence bands for each one.